Okay, hello everybody. Thank you, Norcel, for the organization and for inviting me to this beautiful conference. I'm happy to be here. My name is Yehonathan Sharvit, and I am going to talk about data-oriented programming in Java. So I'm going to present myself so that you know who is the guy in front of you that tell so many interesting things. So I have been a developer since 2001, around 20 years. I've been coding in C++, in Java, in JavaScript, Ruby, Clojure, a bit of Python also. And recently I have written a book called Data-Oriented Programming. So the book presents this programming paradigm called data-oriented programming, and it's not specifically about Java or any other programming language. It's a language agnostic paradigm. It means a paradigm that we could apply to many different languages. And today, during the presentation, I am going to show you how we could apply some of the principles from the book in Java. If you are interested in this topic, you can read more contents on my blog at blog.clips.tech. And if you really like the content that you discover today, you can take a look at the book on Manning website. If you Google data-oriented programming, you will find the book very easily. Feel free to ask questions wherever you want. It's supposed to be an interactive session, so you can open your microphone and ask questions, or you can write in the chat window also, whatever works for you. So what is data-oriented programming? Actually, it's a set of, it's not something new. It's not something that I invented. It is a set of best practices that reduce complexity of information systems. And how do we achieve this reduction of complexity? We achieve that by treating data as a first-class citizen. We'll see a moment what it means concretely. So, but first of all, we need, because the claim is that we are going to reduce system complexity, we need to define what do we mean by complexity. And in fact, in programming, we have two kinds of complexity. We use the same term for two different things. The first thing is computational complexity, which means the amount of machine resources that are required to run a program. For example, you must ask yourself, how many time does my program take? How many CPU operations do I need to run my program? Or you can ask yourself, how much memory do I need to run a program? But that's not the complexity that we are going to talk about today. The complexity that we are going to talk about is system complexity. And by system complexity, we mean the amount of brain resources that are required to understand a program or a system. So when a program is really difficult to understand, we say that it's complex. And when it's easier to understand, we say that the program is simple. And what we want with data-oriented programming is to make our programs and our systems easier to understand for a human being. We don't pretend that it's going to reduce the machine resources that will be required to run the program, but we claim that it's going to make it easier for programmers to understand the program and to maintain the program. and to add new features to the program. Any questions so far? Okay, excellent.
No.
Oh, someone want to ask a question?
No, I said no, thank you. You can go, thank you.
Okay. So, and data-oriented programming aims to reduce complexity, not of every system and every program, but mostly complexity of information systems. And what are information systems? Information systems are systems that manipulate information. For example, a web service that fetches data from a database and serves the data with some manipulation or business logic applied to it as JSON to a front-end application. That's an example of information system. Another example of information system could be a web worker that listens to events on a method broker like RabbitMQ or Kafka, applies some business logic to enrich the event, and with data from other data sources, and passes the event forward, the enriched event forward to another web worker down the stream. And the third example could be a front-end application written in Java or in JavaScript, it doesn't matter, with some application state that need to be managed. What all those kinds of systems have in common is that they manipulate information, and the information is represented with data. So, we are going to present several ways to reduce the complexity. So in order to reduce the complexity, we need first to understand what usually makes an information system complex, hard to understand for human beings. So imagine that you need to build a library management system, an online library management system, where there is a catalog with books, with book copies, and there are users that borrow books and return books. And you need to build a system that manages this information. If you try to implement this system with traditional object-oriented programming in Java, you will find yourself very quickly in a maze of classes and in a complex class hierarchy. You will have probably a library class and a librarian class and a catalog class and a book class and a member class. And that's fine. It's quite appropriate to have a class to represent each entity of the system. But usually in Java, we see that there are classes with many relations that are involved in many relations. For example, here, as you can see in the diagram, we have the librarian class. And this class is in relationship with the catalog class. The catalog uses the librarian class. That's the dash arrow. And the librarian class inherits from the user class. And the librarian class itself uses the member class. And it also uses the book item class, etc., etc., etc. There are many relationships. The relationships between the classes are complex. And it's not only that we have many relationships between the classes, it's also that we have many kinds of relationships. We have association, we have composition, we have inheritance, we have usage. And it doesn't matter if you represent those relationships in a UML diagram or not, the inherently code in object-oriented programming tends to be complex, hard to understand. And the first thing that data-oriented programming says is that if you separate code from data, you will reduce complexity of the system. Let's see how. So if you take this diagram, the UML, the class diagram from the previous slide. You see in the small side of the screen, in the left side of the screen in small, and you take every class and you split it into two classes, where one class has only the methods, the code, and the second class has only the data members. For example, you take the library class and you split it into library code with only static methods, and another class called library data with only data and no code. What happens then is that instead of one entangled diagram, instead of one complex diagram, you get two simpler diagrams. I hope that you agree with me that this diagram in the middle with the S letters is quite simple. And this diagram on the right with the D letters is also simple. And understanding two simple diagrams is easier than understanding one complex diagram. And we achieved this reduction of complexity only by separating code from data. You could say that this separation from code and data is in fact an application of separation of concerns, general principle from programming. Let's see how it looks like in Java in code. Let's take a look at a few code snippets. So imagine that we have the author object in an author object in our system. And for the sake of the example, an author is going to be something very, very simple with a first name, a last name, and the ability to calculate the full name. The full name is the concatenation of the first name and the last name. So what this Prince separation code from data looks like in Java is by having two classes, one class for data, and in this class we have only members, maybe setters and getters if you want, but no logic. And on the author class, on the author code class, we have only logic and no data. So the methods here, all the methods of the author code are going to be static methods. For example, we would have a full name method that receives the author data object as an explicit argument and returns a string that is the concatenation of the first name from the author data and the last name of the author data. How does it look like when we want to use this code? So imagine we create an author data that represents Isaac Asimov, one of my favorite science fiction authors. So here is how we create the data class, quite simple. But when we want to apply the full name method on Asimov, instead of calling Asimov.fullname, we call the static method from the author code and we pass it as an argument the data class that it should operate on. Does it make sense so far? Yes? Okay, let's move on. Okay, another thing that makes code hard to understand is this question that we ask ourselves quite often. Is the variable accessed by reference or by value? And in Java, the rule says that object references are passed by value. I find this rule very, very complicated to remember and to apply. So for me, it's another thing that makes code hard to understand. Let's take a look at an example. So like before, we have separated code from data, and now we have a data class yes, we have the same data class like before, Asimov, Isaac Asimov. And now imagine that author code, we imagine that we have another function in the author code that transform the last name to uppercase. So there will be a method to uppercase, and we pass Asimov, and we receive back another instance of a data class where, as you can see here, Asimov is in uppercase. But now the question is, what happened to the original data class, the Asimov? So Asimov 2, in Asimov 2, the last name is fully uppercase. But what happens to Asimov 1? And by looking at these code snippets, you cannot really know, because it could be that the implementation of 2 upper last name mutates Asimov last name, and it could be that not. You cannot know. You need either to read the documentation of this method and to trust that the implementation is according to the documentation, or to read the code and figure out by yourself whether 2 upper last name mutates Asimov, the class that the data class that it received or not. But anyway, it's a burden on our mind, because we cannot know for sure what happens to the code without taking a look at the implementation. Sometimes people, what they do is, instead of trusting the implementation, they will protect themselves by copying the object. So instead of passing Asimov to this method, to the 2 upper last name method, one way to be sure that Asimov is not going to change is to clone Asimov and to pass the clone, the copy, to the function. So even if the method changes the copy, I don't care, because my original object is not touched. But dealing with copies to protect makes the code even more complicated, not to mention the performance hit that it causes. So that's another source of complexity. Sorry. Oops. Lost my screen. Just a moment. Okay. So that's the second source of complexity. And the third one is what happens when we are in a multi-threaded system. Now it becomes very, very hard to follow. So again, imagine that we have from our library a member data, a data class that represents a member with 3 fields, first name, last name, and a Boolean that says that keeps information whether the member is blocked or not. For example, when a user is late in returning books, the library will block it, and the user will not be allowed, the member will not be allowed to borrow books for a week or 2 weeks. So we keep track of this information with a Boolean. And now, every time that a member wants to borrow a book, we need to check whether it's blocked or not. So take a look at this piece of code, at this naive code snippet. It looks very, very simple, right? If the member is not blocked, I'm going to let her borrow the book. Here in the snippet, I'm just printing the book is yours. So do you think that this code is thread safe or not thread safe? I'll give you a couple of seconds to think about that. Someone would like to answer the trivia? Okay, so the answer is that the code is not thread safe. And the reason is that there could be a context switch between the if and the print. So it could be that in one thread, we check whether the member is blocked, and we see that the member is not blocked because is blocked returns false. But then there is a context switch, and in another thread, the member becomes blocked, but it's too late. We are already inside the code that assumes that the member is not blocked. So this program in a multi-threaded environment will not behave correctly. How do we solve that? We add lock mechanisms. We could define this piece of code as a critical section and protect the critical section with a lock. That's one way to solve the problem, but when we add locks, the code is also we need to give a name to the lock and make sure that we don't use the same lock in different places. And we need to make sure that we don't have deadlocks in our system. So it makes our system more complex than it should be. So data-oriented programming has a very simple answer to those two problems that deals with data mutation. Is simply do not mutate data. If you treat data as a value, if you constrain your program in such a way that data will never change, then you won't have any problem of thread safety, and you will not need to protect with defensive copy. You will not need to read code in order to make sure to discover whether the code mutates data or not, because the data is immutable. So by making your data immutable, you gain a lot of serenity. It makes the code much easier to understand. How does it look like in Java? How do we make data immutable in Java? So as you probably have already discovered, any problem in Java could be solved with the Java annotations. And for example, there is this value annotation from Project Lombok. And what happened is that if you annotate a class with the @ value, then the class is immutable. All the members are automatically final. And you get also for free auto generation of constructor and private field and toString hash code and equals. So it's quite nice, it's quite simple. Simply by adding the value annotation to your data class, you get immutability for free. Another way to do that, if you are lucky enough to be in Java 14 or above, is to use record, which is a new thing in Java. It's natively in Java. It doesn't require any third-party library, and it works almost the same as the value annotation that we saw in the previous slide. But the neat thing is that it's at the level of the language. It doesn't require any third-party library. And again, let's see now what are the benefits of immutable data. Let's take a look again at the code snippet from before. If author data is a record or a value annotated class, then now I know for sure that Asimov last name stays forever Asimov lowercase, because there is no way that this function or any method will change data. So Asimov 2 will contain Asimov last name in uppercase, but I have a guarantee at compile time, if you want, that the original Asimov is not going to be changed. And in a multi-threaded environment, if we take a look again at our riddle, at this piece of code, if the member data is an immutable data, so either a value class or a record, I know for sure that between that the value of member will never change. So if I don't read it again from the database or from an external source, I know for sure that between this line and this line, the member will still be blocked, and actually it will be blocked forever. And that makes the program much easier to understand. You might ask yourself, so if data is immutable, how do we update state of our programs? Because today the member is not blocked and tomorrow it's going to be blocked. Today this book is borrowed by user A and tomorrow this book is borrowed by user B. So how do we manage state in an immutable world? That's a great question. And if you ask yourself this question, I really encourage you to take a look at my book, because I spend a lot of time and pages and illustration and diagrams to explain that in fact managing state with immutable data is simpler than managing state with mutable objects. And it comes down also to the ability to create different versions of data. So if we don't mutate data, let's take a look again at the code snippet, the first one. So we say that Asimov will never be mutated, right? So how do we create a new version of data, Asimov 2? One way to do that is to do a shallow copy or a deep copy of Asimov inside this function and then to mutate the copy. But there are other ways, much more efficient way to do that. And for that, you need third-party libraries like Paguro or Bifurcan. So Paguro and Bifurcan, they implement immutable, in an efficient way, immutable collections in Java. Another library that you might like is JSON from Google. It's a way to convert data object that represent data in Java to JSON back and forth. And there is also a very, very cool library called CQ Engine that allows you to write SQL-like queries on collections that live in the memory of your program. Sometimes you need the same ease. You need to be able to query data inside your program with the same ease as you query data in an SQL database. So CQ Engine implements all the SQL functions so that you can query your data inside your program. And those libraries allow you to embrace data-oriented programming inside your Java program. And you could decide to go, for example, when you write a new program from scratch, you could decide to embrace data-oriented programming approach all across the board. But if you work on a code base with thousands or millions lines of code, you're not going to rewrite everything. But you could decide what are the more appropriate modules that you might want to refactor into a data-oriented programming approach in order to reduce complexity of your program. So if you find this topic interesting and if you think that it can be relevant to what you do at work, you might want to take a look at the book. And in the book, I am explaining in great detail how to implement efficient immutable collections and how to use them, how to represent record with immutable maps, how to do polymorphism without objects. And as I said, how to manage the application state where all data is immutable, and also how to build a highly scalable concurrent systems where you could receive thousands or thousands of requests per second and manage them in a highly scalable way without any locks. How to access data from the database with less code and simpler code. So all those topics and more are covered in the book. If you find it interesting, I invite you to take a look at the book. And that's all I had. I'd be very happy to take questions or to hear insights or whatever. So if someone wants to open the mic, it's now or never.
Hello. Yes, there are two questions, but also some comments. Because, as you said, immutable data. These concepts also are in domain-driven design as value object. Aren't they similar? This is a comment. Mm-hmm.
Yes. So let me address this comment. Yes, it has lots in common with value object and data domain, data-driven design. The difference, I think, here is that we put more emphasis on the fact that data is immutable. And also I think it's simpler to apply than data domain design, because data domain design, data driven, domain driven, I forgot, data domain design or data driven design, it takes you to lots of concepts and terms, and in order to embrace this paradigm, you need to make lots of changes to your program. So in a sense, data oriented programming is a summary of all those great ideas.
Thank you. Also, there is another comment. Also, effective Java from Joshua blog says immutability is very important. So also it's very similar what you say. So it's a concept.
Yes, definitely. Immutability is very important, and nowadays in 2021, it's quite easy to embrace immutability due to the third-party libraries that I mentioned before, like Paguro and Before-Can.
Okay. So there's one question. So, for example, if we use Jakarta Enterprise or Java Enterprise Edition, how those practices are effective? Do you have any story like this?
No, I don't have an answer about that, but I am in touch with an expert from the Jakarta Enterprise. I forgot his name, something like Otavio or something like that. And he was very interested by the book, and he read the book, and he told me that he's going to teach the Java community how to apply the book principles to Jakarta.
Great. Yes, so far these are the questions. Also, I'm watching the questions, but no questions. Are there any questions, my friends? We are waiting for the questions. If you want, you can post your question to the question part. I can read it for you.
It would be very nice if someone opened their microphone and ask a question.
Yeah.
Hello, I'm Tushat. If there's too many state changes in our program, and if they are fast, is it effective to use data-oriented programming method?
Sorry, say it again. I couldn't hear your question.
If there are too many state changes, and if they are fast in time, then
yes, so that's a great question. That's a great question. If there are too many mutations that happens at once, in theory you could have a problem, but in practice, the mutations that happen concurrently will not be to the same pieces of the data. So, for example, it's not that in 1 second you will have 1,000 queries for borrowing the same book. You will have a mutation that wants to borrow book A and another mutation that wants to borrow book B and book C, etc. And there is no problem of merging all those mutations together. And there is in chapter 5 of the book an illustration about how to merge concurrent mutations. And it's quite similar to what happened to Git when two programmers check out a branch and they commit. So if the programmers did their changes to different files, there is no problem. If they touch the same file but different lines, there is also no problem. If they touch the same file and the same lines in the file, then you have a problem. And this is what we call optimistic locking. So instead of locking a priori and forcing all the mutations to wait until mutation number 1 is done, you do optimistic locking. You don't lock, you calculate what would be the next state if the mutation succeeds. And once you have the next state, you check whether it's in conflict with other mutations that happen in the same time. And usually for most applications, this approach, the optimistic locking approach, is much more efficient and scalable. That's, for example, how Elasticsearch works. When you do, I don't know if you're familiar with Elasticsearch, but it's a highly scalable database. And the way it works is that when you want to update a document, you need to specify what is the version of the document that you update. So for example, you read the document version 10 and you want to update. When you update, you say, okay, I'm going to update version 10. If when you update version 10, someone has already updated to version 11, then your mutation is going to fail and you will have to retry. And it's more scalable than the usual approach where you lock and you cannot apply any change until the others are done with their changes. Does it answer your question, my friend?
Yes, yes.
Yes,
It's
we have a question. So we
Thank you.
just post to your chat. Can you
Mm.
see your chat screen?
Yes, yes, yes.
Jonathan?
Yes,
Okay.
I'm going to read the question. Yeah, that's a great question also. How would we deal with limitations imposed by frameworks when we cannot provide immutable data structures? Great questions. We have two kinds of issues. One issue is solvable and one issue is not. One situation is solvable and one situation is not solvable. Let's start with the non-solvable situation. If you use a framework that mutates data, then you are there is nothing that you can do. But if you use a framework that, for example, read a map, then the framework doesn't care if the map is immutable or not. And actually, Paguro maps, the third-party library that I mentioned here, Paguro in Java, the immutable collection that Paguro provides implement the Java collection interface. So from the perspective of the framework, the framework doesn't know that it's an immutable map. It thinks that it's a regular map. The only thing is that if you try to use a method that mutates the map, like set, to set a new key on the map, then it will throw an exception. Okay? Great question. Come on, ask more questions, guys. I really like your questions. It's very interesting. What I like the most when I prepared this presentation is that I discovered that actually immutability is coming in Java. So since Java 14, you will have the possibility to create immutable records. And that's, I think that when Java 14 is going to be adapted more and more, the frameworks also will have to adapt and to embrace immutability, because the language itself promotes immutability. So it's in continuation to what's the Joshua book, that immutability is very important. We had since forever the ability to define private fields in a class, but since Java 14, we can define immutability at the level of the class itself, not only at member by member. So that's an interesting move of the language. And as I say, data-oriented programming is not something new. It's a set of best practices that good developers have been applying forever. The thing is that in data-oriented programming, we formulate them clearly as clear, concrete principles that you could apply to your program. That's the novelty of the book, if you want. It's not a new paradigm. It's a new presentation of a well-known set of best practices. Well-known by experts. Oh, there is another question here. Would reflection be the worst enemy for such a mindset for immutability? It depends. It depends, because I think that what you mean by this question is that with reflection, you can take a field that is immutable and make it, that is final, and make it non-final. And even though in the class it should be immutable, you could transform it and make it mutable. So first of all, I don't know what's going to happen with Java records, if they block that even through reflection you cannot make an immutable member to be mutable. Yeah, so in a sense, reflection is could be the worst enemy, because it could destroy all the rules that you try to make in your programs, and that your compiler, even if your compiler say yes, here you are guarantee, 100% for sure that data is immutable, with reflection you can break that. Oh, another question related to optimistic locking. Optimistic locking is not good if there are a lot of conflict. Yes, but lots of conflict, it doesn't happen quite often. It's very hard to think about an application where there are lots of conflict in parallel. Think about Google Docs, for example. Google Docs allow, I don't know, hundreds of users to edit the same document in parallel, and they use optimistic locking, because at every point in time, the number of users that are going to change the same word in the document, it's not so high. So instead of punishing everyone, the readers, the writers, and makes a degradation of performance with locks, we prefer to do optimistic locking, and if it doesn't work, we send a message, we abort the mutation. We say to the user, no, you change cannot work, and it's inherent to the, it's not an implementation detail. It's inherent to the situation. If two users, think about the Google Doc example. Imagine that two users at once wants to change the title of a document. There is no way that you can apply the two mutation, right? Some of them is going to win. So one is going to win, and now the second one that somehow got a bit later into the code that update the title, instead of applying its mutation blindly, you're going to send him a message and say, no, in the meantime, you wanted to update the title, someone else updated the title. You need to think again. I cannot let you update the title blindly. So quite often, if you are in a situation, in an application where you have lots of conflict and it's write intensive, then inherently you have a challenge that you need to solve. And regular locks, I'm not sure that they will help you to solve the problem. But most applications that I know of are read intensive, not write intensive. So for every write, there is, I don't know, 10 reads or 100 reads. So usually, optimistic locking is the most recommended approach, but there are exceptions for sure. Also, great question. And another a way to solve the problem, again, the problem of optimistic locking is to add a message broker in the middle. Instead of applying the mutation directly, you could send each mutation to a queue, and then you know that they're going to happen one after the other. And it relates to CQRS, if you guys are familiar with common query responsibility segregation. Okay, another question. If your mutation generates an exception because of a conflict, you must plan the code to tackle the problem, and your code is more complex. No. Yes and no. there are several ways to handle a conflict. One way, the simplest one, is to send a message back to the user. Your mutation has been aborted due to a conflict. Please retry. And it's not complex. For example, if you implement an HTTP server, once you detect that the mutation has failed, you send back, I don't remember the error code 400 or something like that. You have a problem. I think there is an HTTP code, a special HTTP code for conflict. HTTP, let me see. Yes, you send back 409, means conflict. So it's not complex. If you want to try to be smart, you could retry. So mutation A happens in parallel with mutation B. Mutation A completed before mutation B. When mutation B completes, there is a conflict. So one way is to abort. Another way is to retry mutation B and recalculate the effect of mutation B after the state has been updated to by mutation A. And then you can retry and decide how many times you want to retry, etc. But I think, again, in many situations, simply aborting and sending back a message to the user is enough. Also, great question. But it doesn't make the code more complex. I think it makes the code simpler in a sense because there is no locks and no deadlocks. Yes, more complex for the client who receive the message. Yes, totally right. If it's a front-end application and the front-end, but anyway, a front-end application needs to handle errors. I mean, there could be many different errors. It could be a conflict. It could be a timeout. It could be that the database is not available. It could be a network outage. There could be so many errors that anyway the front-end needs to handle errors. But it's true. You know what? You put me in the corner. It's true that if you had logs everywhere, somehow the management of conflict in mutations is, let's say, easier, because the mutations will happen one after the other in sequentially and not in parallel. But the fact that they happen sequentially, not in parallel, has a performance impact. So it's a trade-off. Okay. Is it possible to score software for DOP? Like Richardson maturity model. I'm not familiar with Richardson maturity model. It sounds very interesting. I'm going to Google it. If you want to send a specific link, I will be very happy. Oh, that's a model that breaks down the principle, the 3 steps. Oh, very interesting. Thank you. I'm gonna. It's not an. I cannot read that in 5 seconds, but to me it seems very interesting. What I like. I don't know who is the guy that asked the question. If you can write down his or her name, it would be great. To me, it relates to another idea that I had and I couldn't find an answer. Yeah, you saying Agdogan. Great. I'm going to put here my Twitter handle, and if you'd like to chat on Twitter, I would be very happy using Agdogan. And for all the others, and for you also, do you guys agree that the diagram in the right is simpler than less complex than the diagram in the left, where every node has been split? If someone wants to say that he or she agrees or disagrees. And I'm looking for a matrix that would prove that, a matrix that measures complexity of a system. And if we would be able to prove that the system on the right is less complex than the system on the left, I will be very, very happy to be able to measure the complexity quantitatively. So if someone is aware of a metrics, how to measure complexity of a class diagram, please contact me on Twitter or on my blog, on my email. It's not difficult to find me on the internet, and send me a message. I'd be very, very happy to. Or if someone has an idea about a Richardson maturity model, also. There is something, you know what? There is a metric that says how many functions in your code base have side effects. How many functions mutate data? How many functions deal with state? Because like I said, at the end of the day, you need to manage state, right? We don't live in an ideal world where we do only calculation. At the end of the day, we need to mutate state. But the question is whether the mutation and the side effects and the member updates are spread out everywhere in the code, or it's located in only in a small layer at the code. And if you are able to write a program where 99% of the code deals only with data calculation, 98% of the code, and only 2% deals with applying the mutation, validating that, checking for conflicts, etc., then you are in a good situation. And I think there is a way to measure that. So it could be a way to measure how much a system is DOP friendly or not. Wow, so many great questions. I'm really excited. Thank you, guys. Thank you. I think we have another 7 minutes or so. So if someone else wants to ask questions or share insights or whatever. Okay, so I think we can call it a day. Thank you for your listening and your questions and your insights. Has been a pleasure to be here. If you want to reach out later and contact me by email or Twitter, or I'm going to put here my email. I would be very happy to connect and to hear your thoughts on this topic. So thank you again for the organizers. It has been a pleasure to be here.
Yeah, thank you, Yehonathan. And actually, I want to thank to Kürşat, Moran, and Richard for their good questions. They get rich this session. So, and thank you for your valuable informations. This is okay for now, for today, and we will close the conference for today. See you tomorrow. And thank you again, Yehonathan.
Thank you.
Yeah, bye-bye.